So if everything is working correctly, we should see this is going to stop right now. Nice. Hi and welcome to this new video tutorial. We're going to demonstrate today how to build a prototype using a conveyor belt, a Raspberry Pi and Opencv. We will show in this specific case how to detect nuts. We have hexagonal nuts with different sizes. So we have a bigger one and smaller one. Our goal in this project is to put all the small ones inside this box. So if this runs, all the small one will go inside this box. Then when we get to the big one, we want just to take this one out. Of course, I'm doing that now manually, but we will do that using Opencv. So Raspberry Pi will detect what's exactly here on the belt. And so this is a really useful project for companies, for industries, because on a large scale, you can detect the objects passing on the belt. You can detect the quality of the objects. And if you connect this with a robot arm, you can, for example, separate on each boxes, like put the correct nut on the correct box, or different objects on a different boxes just on one conveyor belt. So it will take small one in this box, then the arm will take the big one on some other place. But you can use this in many different ways. So if you're curious to see how this project is going to work and how to build it, keep watching and let's start. Let's start by importing the libraries. So we're going to import CV2 and then we're going to import NumPy as NP. As first thing, we're going to load the webcam. Cap is equal to CV2.video capture 0, and 0 is the first webcam. If you have more webcams, the index can be 1, 2, and so on. Then we take the frame in real time from the webcam, while true is then underscore, because we don't need this value, that's why we put underscore, and then we just need the frame is equals to cap.read. Then we want to show the frame on the screen, so cv2.im show the name of the window. Let's just call this one frame, and then what do we want to show? We want to show frame, so we put frame right here. Then a wait key event, so that we can press the key in real time while we're running the video. Key is equal to wait key 1, so we're going just to wait 1 milliseconds between each frame. And then if the key is equals to 27, and 27 is the S key on the keyboard, in that case we want to stop, so we break the loop. Once we break the loop, we're going to release the camera because we don't need it anymore, cap.release. And then we want to close all the windows because they're not going to close just themselves automatically, so we need to close them by writing cv2.destroy all windows. Just a typo here, it's not just wait key, but it is cv2.wait key. And now, before proceeding, I'm going to run the script to be sure that everything is written correctly. So let's press run, and everything is running fine right now. Here it is the conveyor belt that I have at the moment. Now, what's the goal of the project? If you see here, we have different hexagonal nuts. We have 1, 2, 3 small of them, and then a big one. We want to examine all the nuts passing in real time, and for example we can say that we want to focus on the small ones and we want to stop the belt if there is some big one. So let's, as first thing, just try to detect the nuts on the belt. How do we do that? Well, let's take a look at this frame. We see here we have the conveyor belt, then we have many other things on the screen that we don't need. The first operation that we have to make is to simplify everything. So what we do, we just cut the belt because we just want to focus on the belt. And so belt is equals to, well, now we need to cut this from the frame. I don't know exactly the position of the belt, so we're going to check where the belt is located on the screen. And it is really simple. When you use Opencv on the Raspberry Pi, you can see here that we have the coordinates of the mouse on the screen. So we just place the mouse on the top left on the screen of the conveyor belt, and I see in my case X 139 and Y 210. So let's keep these informations. X, I already forgot them. X 137 and 209, 137 and Y 209. And then we need to see where this ends. So we take the top left and then we take the bottom right point. Bottom right is equals to 530 and 327. X to 530 and I don't have a good memory, 327 I guess, 327. And so now that we know the coordinates, we are going to use these coordinates to cut a region where there is a belt from the screen. So the belt is going to be equals to the frame, and from the frame we're going to cut this specific area. So frame we have from, keep in mind that when we work with the frame, first we work with the rows which corresponds to the Y, and then the columns which corresponds to the axis. So first we say we want to take from 209 to 327, and then we want to take from 137 to 530. And to make sure that this is correct, we're going to show on the screen just the belt. cv2.im show belt, and then belt. And now let's, I'm going to stop everything and let's run this to see if we have just the belt. And that's exactly what I wanted to achieve. So we just cut a portion of the belt so that our detection is more simple. Now, how do we detect the nuts on the conveyor belt? It's always better to use the most simple approach possible. And in this case, as if we consider the nuts have most likely always this color and the belt is almost always black, at least this belt is black, then we can just use a simple threshold operation. So the threshold based on the value of the pixel, and in this way we can simply detect the nuts. So let's do that. In case it's not clear now, everything will make much more sense. First thing, we're going to convert the frame to grayscale format. So frame is equals gray frame is equals to cv2.cvt color. So we want to convert the frame, and then cv2.color we want to convert the BGR format to the gray format. So if we show cv2.im show frame gray and then frame, no, gray frame, gray frame. Let's run this one. Here is the frame in a grayscale format. Now we can apply the threshold on this one. Instead, we won't focus, of course, on the belt. So we did the conversion on the gray frame, but we will focus on the belt. So better, let's do this on the belt. So instead of gray frame, which most likely we don't need, let's say gray on the belt. Gray belt is equals to belt cv2.cvt color. We want to convert belt, and then cv2.color underscore bgr format to gray format. On the gray belt, we will apply a threshold, and if it is not clear what is threshold, let me show what it is and you will get it. Underscore threshold is equals to cv2.threshold. We want to apply the threshold on the gray belt. Now we say that all the values above 50 will be converted to 2055. cv2.thresh binary. Binary, okay. And now let's show the threshold. Threshold and then threshold. And let's run this one. Okay, what you see here exactly, we are converting all the, let's say, gradient colors close to the black, we're converting them to a complete black color. All the things like this hexagonal that are not so close to black, we will convert them to completely white. So the threshold, it is a way to convert a gray image to, instead of having different gradients of gray, only white or only black. The fact that you see here this thing is because the lightning, even if it's not clear to our eye, here there is some lightning change. That's why here we have this. We can solve this just changing the threshold value. So instead of 50, we can, let's say, increase this one. So let's see this. Okay, not perfect, but for sure a really decent result. So there is some really small noise, but it is in general a great result. So if you don't get it right, you have to play around with the threshold value. And to understand better what is threshold, I will not go deeper in this one, but there is some other video I've done about threshold, so you can check it out. Instead, let's now move on. Now we're moving on by detecting exactly these white objects. So let me show this again. Now we somehow made a distinction black and white. So black, we don't need the black, it is the conveyor. And white, what is the white? White are the hexagonal nuts that we have. So now using the Opencv function find contour, we're going to find the contours, so the boundaries of all the white objects that we have on the screen. So let's do that. Also, I'm going to put some comments. So here, ROI is the region of interest. So in this case, is the belt. Let's, instead of ROI, let's say belt. Let's keep simple words. Why make things complicated when it is not necessary? Belt, and here detect the nuts. So underscore contour, then underscore is equal to cv2.find contours, and then we're going to find contour on the threshold, then cv2.ret external, and I will explain this quickly in a bit. cv2.chain approx simple. Let's now draw the contour. So for CNT in contours, let's print them. I will quickly show what is this. So here in CNT we have a lot of coordinates, and these coordinates represent the boundaries of each white object that we have. So in this case the white objects are the nuts, so we have the coordinates of the nuts. And now we will take a rectangle and we will draw the coordinates of this. So we have a function from Opencv which bounds a rectangle from these coordinates. So we have x, y, width and height of the rectangle is equal to cv2.bounding rect of CNT. And let's show a rectangle for them. cv2.rectangle, and rectangle, we want to draw the rectangle on the belt, and then we have the top left point of the rectangle, which is x and y that we just got on this function, and then the right bottom point of the rectangle. So we have x plus the width and then y plus the height. Let's make green rectangle, so it will be the color 0 blue, 2055 of green and 0 of red, and let's make them thick 3 pixels, and let's draw this on the screen. Okay, now you see this interesting result. We have boundaries surrounding the nuts, 1, 2, 3, 4, and also we have some noise here. So of course it is not perfect, so some lightning change, or like the conveyor belt doesn't have a complete black belt, but here there is some difference in lightning. But anyway, that's not a big deal. It is not a problem for our project. So even if there are ways to remove them, they don't disturb us, so we can keep them. Instead, let's focus on our real goal. Our real goal is to distinguish between the small nuts, so small, we have 1 to 3 small nuts, and the big one. To understand the difference between them, we can calculate the area that they have. So let's calculate the area. Calculate area. Area is equals to cv2.contour area of CNT, and we can show the area for each one of them. We can say, for example, cv2.put text. We want to put the text on each contour so that we can see the area in real time. We want to put the text on the belt, of course, and then we need to define which text do we want to show. We want to show the string of the area. So area is a number, but when you put the text, you need to convert it into string format. So that's why we use str area. Then where do we want to place the text? We want to place the text just on X and Y. So on the top left point, let's put it there. And then we have the font of the text. So here different number corresponds to different font. And then we have the size of the text. So I will put, I don't really care about the font, so I will just put 0, whatever font it is. And then we define the color of the text. Let's use maybe green color 02550 also for this one. Let's see if this is visible. Okay, we see a lot of numbers and it is a bit of a mess. So maybe let's try changing the font, a smaller font. Let's try with 1. And also I want to change the color of the boundaries, because if we use green for everything, then it is not so clear. And also let's show the text as last element, just after the rectangle. Otherwise the rectangle, it is covering the text. Let's run this. Okay, wow, much nicer. Let's see what is happening here. We see small nuts have the size around 278, this one to 27 to 30, while this big one has a value above 500. So just using the area, we are right away able to distinguish them. So we can say if the nut is bigger than 500, for example, after the area, so distinguish small and big nuts, and we say if the area is greater than 500, so we have a big nut. So in this case we have big nut. And what do we want to do? We can, for example, draw a red rectangle to make it stand out on the video. So instead of 25500 blue, green, and red, we say 0 blue, 0 green, and 255 of red. Instead, if the area else, if the area is smaller, so it is a small nut, and we draw just a blue rectangle. And let's run this. Okay, now you can clearly see the difference between them. Right away, even with the code, we know that this is a big nut and they are small nuts. Plus these small values that we see here, we can remove them. Actually, let's remove them, so we will make this project even more clear. So if the area is greater than 500, and if the area is small than 500, let's say that the small nuts are between 100 and 400 pixels in sizes, the area. So if 100 is less than area, and if area is less than maybe 500, let's keep it this way. So all the elements below 100, we don't take them into consideration. Even if we see the numbers, we're not surrounding them. We could even remove the numbers, but I don't want to waste time on these details that don't really matter right now. Now, next step. we need to find a way to move the belt. So switch on and switch off the belt. The belt is connected to a relay, which is connected to the Raspberry Pi, and I have a library to switch it on and switch it off. So let's load our conveyor belt library. Well, this is a custom library I quickly created myself. I just called it conveyor lib. And we need to import this one. Import conveyor lib, and conveyor lib dot conveyor. We create an object relay. I guess it's written this way, relay, and we want to turn on and turn off the relay. When we turn on the relay, of course, the conveyor will start running. When we turn it off, it will stop. And it is really simple. Now I will give manual command with the keyboard. So here I will just add 2 lines regarding that. If the key is equals to, let's say that if we press the letter N on the keyboard, we're going to switch on the belt. So Alt N, and then relay dot turn on. It is just that simple. If the key is equals to, if we press the letter M instead, we're going to turn it off. Or M relay dot turn off. And let's see if this works correctly. So let's focus now on this big image. So I press letter N, and you see it is running correctly. And for some reason, okay, now we see, okay, I press M and it stopped, but we see that, of course, because of the distance of the camera, now the object there, when they are in this part of the belt, they look smaller. So our condition 500 plus and 500 less, it is not working correctly. So we need just to change the values, but for the moment, let's keep this going. Okay, I will just change this one 400 and 400. Now we are at the last part of the project, and in this part we just want to stop the belt if we detect that there is a big nut on the belt. So we know that here area detects big nut and here it detects small nut. So here we need to add something that stop the belt if the we detect big nut. And we stop the belt, so relay dot turn off. It is the same function I used before. Let's try this. Okay, but before I have to take all of them. I have them here so that I can place them again on the belt so that we can test in real time. So, okay, I'm going where the belt is, so just here on my side to test it. Okay, the belt is empty, so let's now switch this on, and it is going even if we don't see it. And now, okay, it detected my hand, and my hand, it seems it's big, so so there is something to work on. It wasn't supposed to stop right away. So one thing that we can do is, here is the start of the belt. We want just not to focus at the start, but at the end of the belt only. So we can somehow cut the area that we are considering for the belt. So instead of taking from, let's see the values that we have. We are taking from 209, 227 is the height, so that's the same always. From 137 to 530. Instead, let's take from 137 to 250 or a bit more, 280 maybe. And let's see what we get. We have just a small portion now of the belt, which probably is enough. So let's test this one now in real time. I press N and it is on. Let's see when we see this one passing on this small screen. Well, that's nice. So that's what we need exactly. So I'm going now to test it. Small nut, another small one, and now let's try with a big one. So if everything is working correctly, we should see this is going to stop right now. Nice. That's exactly what we wanted. So I take it out. It keeps going, and I will put another small one. Let's steal some color from the box. And let's see what is happening now. Nice. Well, as you can see, this is a really simple version of this project. Of course, it can be improved in many ways, but we achieved our goal with just Opencv and a really simple code, I can say. And this, of course, is really useful on industries. If you want, for example, if you have, let's say, for example, nuts, you have many of them on the belt of different sizes, and you want to put each size on a separate box, so there could be a robot arm which takes them based on their size, and they put in the right box for each of them. You could use this approach to detect if there is some element which is not the nut, but of course you can use this for any object passing on the conveyor belt. You can check the quality of the products, you can check if there are bottles, if there is something wrong with the bottle, if there is some sticker, you can see if it's not printed correctly, and so many other things that you can do with this. Hope you enjoyed this project. I will be still also releasing soon other interesting projects like this one. So if you want to see them, stay updated, and see you in the next video.